Hi everyone, my name is Ricky. My team member Rithika and I are excited to share a project with you today. Throughout this presentation, we'll walk you through the key aspects of our work. Starting off, Rithika will be going over the main rationales of our project, and her insights will provide a comprehensive understanding of our development.
Hi, my name is Ritika. So the topic we chose for our project is a healthcare scheduling application. It is designed to revolutionize the way we manage appointments in the healthcare sector. Its significance lies in its ability to improve the overall quality of healthcare services. By streamlining the appointment scheduling process, the application enhances patient satisfaction by offering a convenient and user-friendly platform where patients can easily book, view, and manage their appointments. This not only optimizes the use of healthcare resources by ensuring that doctors' schedules are efficiently managed, but also reduces administrative burdens by centralizing records and automating notifications. Primary motivation for developing this application is to address the inefficiencies and complexities associated with traditional appointment scheduling in healthcare. Traditional methods often lead to long waiting times, double bookings, and missed appointments, which can negatively impact patient care and satisfaction. By digitizing and automating the scheduling process, the application aims to create a more organized and efficient system that benefits patients, healthcare providers, and administrative staff. This project aligns with the broader trend of digital transformation in healthcare, aiming to create a more responsive, accessible, and effective healthcare system for all stakeholders. The healthcare scheduling application encompasses several key functionalities designed to enhance the overall user experience for patients, doctors, and administrators. First is user authentication. The application provides a secure login and registration system for patients and doctors, which ensures that all user data is protected and that access to the system is controlled and secure. Patients can create accounts to manage their appointments while doctors can log in to manage their schedules and handle administrative tasks. The second main functionality is appointment scheduling. A central feature of the application is its robust appointment scheduling system. Patients can easily book, view, and cancel appointments with doctors all in real time. This functionality provides patients with flexibility to manage their healthcare appointments conveniently and ensures that they have access to up-to-date information about doctor availability. Real-time scheduling helps reduce waiting times and enhances patient satisfaction by allowing for more efficient appointment management. Lastly is doctor management. For doctors, the application offers a comprehensive management of their schedules and appointment requests. Doctors can update their availability, view incoming appointment requests, and make adjustments to their schedules as needed. This feature ensures that doctors can manage their time effectively and reduce the likelihood of double bookings or missed appointments. It also allows doctors to get notifications if an appointment gets changed or canceled. Overall, these functionalities work together to create a seamless and efficient appointment scheduling system. The healthcare scheduling application is designed to achieve several key goals. For patients, the application offers the convenience of online booking and management, allowing them to schedule and manage appointments effortlessly at their convenience. It also provides real-time updates on appointments and doctor availability, ensuring patients are always informed and can plan accordingly. For healthcare providers, the application streamlines scheduling, making it easier for doctors to manage their time efficiently and avoid overbooking or scheduling conflicts. Automated notifications are also sent to patients, reducing the number of no-shows and ensuring better utilization of resources. From an administrative perspective, the application offers centralized management of records and appointments, simplifying tasks and reducing paperwork. This centralized approach, combined with the digitization of records, minimizes errors and ensures data integrity, which leads to more reliable and accurate healthcare. So this is how our UI looks like. Our app is called MediMeet, as shown in the opening image. These screens display what a user would encounter when setting up an account. The second screen is a welcome page with login options. The third screen is for creating a new account if they do not have an account yet. And the last screen prompts the user to select their role as either a patient or a doctor. The overall design uses a clean, minimalist approach with a blue and white color scheme. If the user selected his or her role as a doctor, then these are the screens they will be able to view. After selecting their role, the provider would have to verify their credentials and can only access their portal once their verification process is approved. These screens show the different functionalities available to doctors, such as viewing patient information, managing appointments, and checking notifications. There's also a profile management section where doctors can edit their information and select their availability. Similarly, if the user selected his or her role as a patient, then these are the screens that they will be able to view. The flow starts with selecting a location and move through steps like exploring doctors, booking appointments, viewing notifications, and managing your profile. There are also screens for payment options and confirmation pages. The layout gives a good overview of the patient's journey throughout the app, from finding a doctor to completing a booking.
Thank you, Ritika. It is time for us to delve into the specifications of our database. The entity relationship diagram illustrates our management system consisting of 6 interconnected entities. Each entity is connected through various relationships that depicts the interactions within our scheduling system. The appointment entity captures essential data about each medical appointment to ensure a structured record of all appointments. Billing invoice manages transactions related to appointments. This entity is pivotal in tracking and managing the billing process. The payment entity records the payment transactions made by patients, ensuring accurate financial records. The provider entity stores information about healthcare providers, facilitating the management of provider details. The patient entity keeps comprehensive records of patients, ensuring that all patients-related information is readily available. Lastly, insurance company links patients to their respective insurance providers and coverage. For this project, we utilized MySQL to create our database. MySQL was chosen for its robustness, scalability, and ease of use, which are essential for managing the complex data relationships depicted in our ERD. Using MySQL allowed us to efficiently handle and query the data, ensuring reliable performance and data integrity. The following is the SQL script that we use to create our tables corresponding to our ERD. It defines the structure of each table, including the primary keys, foreign keys, and various constraints necessary to maintain the relationship and data integrity within the database. By carefully designing the database schema and leveraging MySQL's capabilities, we were able to implement a well-structured database that effectively supports our healthcare management system. After we created the database, we inserted data samples for testing purposes. This is a crucial step as it allows us to verify the integrity and functionality of our database. In this step, we can thoroughly test the relationships and constraints defined in our schema, ensuring they operate as intended. This testing phase was dedicated to perform a variety of queries that simulate real-world operations within our system. In the next slide, we'll showcase a live demo. In this demo, I'll be going over different queries that simulate real-life operations within our system. Starting with the first query, we're looking to retrieve all patients' names and their insurance provider. From the result grid, we can see the corresponding output, including patient name and the insurance company name. Moving on, we're going to find the number of appointments of each provider. Moving on, we can also list all patients with unpaid bills. From the result grid, we can see there are a total of 4 patients who have not paid their bills. Moving on, we can also get the details of all appointments with pending status. Moving on, we can also retrieve all patients' names and the total charges of their billing invoices. From the result grid, we can see the corresponding output, including patient name and total charges in a descending order. Moving on, we can also find all patients who has an appointment with Dr. John. Lastly, we can also retrieve the list of all providers and the total amount they have billed. After seeing the executions of our queries, let me explain each of their functionalities. For the first query, we use an inner join to combine the patient and insurance company tables based on the insurance ID. This ensures that only records with matching insurance ID values in both tables are included in the result. For the second query, a left join is used to combine the provider table with the appointment table based on the provider ID. This includes all providers, even if they do not have any appointments, as the left join ensures that all rows from the provider table are included, and any non-matching rows from the appointment table result in no's. The count function is used to count the number of appointments for each provider, and the results are grouped by the provider's name. For the third query, an inner join is used to combine the patient and billing invoice tables based on the patient ID. This ensures that only records with matching patient ID values in both tables are included. The where clause filters the result to include only those billing invoices with a billing status of unpaid, listing the names of patients with unpaid bills. For the fourth query, this query uses an inner join to combine the appointment, patient, and provider tables. The appointment table is joined with the patient table on patient ID and with the provider table on provider ID. The where clause filters the result to include only those appointments with the status of pending. For the fifth query, this query uses an inner join to combine the patient and billing invoices table based on the patient ID. It groups the results by the patient's name and uses the sum function to calculate the total charges for each patient. The results are then ordered by the total charges in a descending order. For the sixth query, this query uses an inner join to combine the patient, appointment, and provider tables. The patient table is joined with the appointment table on patient ID, and the appointment table is joined with the provider table on provider ID. The where clause filters the result to include only those appointments with a specific provider. For the last query, it uses the inner join to combine the provider, appointment, and billing invoice tables. The provider table is joined with the appointment table on provider ID, and the appointment table is joined with the billing invoice table on appointment ID. The results are grouped by the provider's name, and the sum function calculates the total charges billed by each provider. This will be the end of our presentation. We hope you found it to be informative or valuable. Thank you for your time and attention.